Okay, so very last question. It is an optimization question. It's kind of like that tenant-landlord question that we did. So you're trying to maximize revenue for a stadium. And the word problem says a hockey team plays in an arena with a seating capacity of 15,000 spectators. With the ticket price set at $12, average attendance at a game has been 11,000. Okay, so what's going to happen is if you charge less for a ticket, more people will come. And so the problem says a market survey indicates that for each dollar the ticket price is lowered, average attendance will increase by 1,000. Great. Okay, so more people are going to come, but you get less per ticket. So there is some sweet spot, some perfect price for a ticket that's going to maximize the revenue, right? Because if attendance is high and people are paying nothing, then you don't get anything. But if attendance is low and people are paying a lot, it's still not going to be great. So we're trying to find the sweet spot right in between. Alright, so we just need to set up a function to maximize. Obviously, it's going to be the revenue function. So how can I describe the revenue? Well, it's just, let's let x equal the number of people attending. So attendees. And let's let y equal the ticket price. Okay, so price per ticket. So then you can see the revenue for a game is just going to be x times y. Okay, so you're saying take the derivative, set it equal to 0, and solve. And that's true, but first we need to get the function down to just one variable. So we need to write down a relationship between x and y that lets us express one in terms of the other. And we're going to use this market survey sentence. A market survey indicates that for each dollar the ticket price is lowered, average attendance will increase by 1,000. So let me see if I can write x in terms of y. Okay, so x is the number of attendees. So let's just imagine that normally it's 11,000. Tempted to just write 11 and have thousands be the units, but let's do that. Okay, so typically the attendance is 1,000, but then what happens? For each dollar the ticket price is lowered. Okay, so it's going to be increasing. Now how do I say this part? For each dollar the ticket price is lowered. So let's call that 12 minus y. Okay. So those will be the number of dollars that the ticket price has been presumably lowered. And for each unit in here, or this amount, whatever, we're going to multiply it by 1,000. So that quantity times 1,000 is the number of cheapskates that come to watch the game at a lower price. Alright, and so now I have an expression. It's just in terms of y. So I can write this function r of y equals x times, no, sorry, I'm doing it wrong. I'm going to write all this stuff in for what x was. So I've got 11,000 plus, let me multiply this in. What is it? It's 12,000 minus 1,000y. And this is all times y. So let me get this cleaned up before I take the derivative. I will be taking the derivative in a second. So put these two together, what do you get? You get 23,000. And so you multiply in the y and you get 23,000y. And you multiply the y in here and you get minus 1,000y squared. Y. Okay, so now we're ready to take the derivative. So take the derivative with respect to y, of course. Y. And you get 23,000. And here you get minus 2,000 y equals 0. So now you just have to solve. totally boring, right? What's easier than solving algebra problems? Let's do it like this. 23,000 is equal to 2,000y. And let's stop torturing ourselves with these thousands. Divide both sides by 1,000. And you get 23 is equal to 2y. Divide both sides by 2, and you get y is equal to 23 over 2. Aha! And all along it was our old nemesis 11.5. Okay, so we just found the perfect ticket price. So the perfect ticket price is 11.5. Now you're thinking, did you just accidentally minimize revenue? Because that wouldn't be good. Well, I guess I should check to see if this is a maximum or a minimum, but whatever. And these problems that almost never turns out to, they never trick you, or it's always just the thing. So relax. And we could figure out the number of attendees if we wanted because of this relationship. So the number of attendees is going to be, this will be 12 minus 11.5 will be 1/2. So the number of attendees that you'll get, x is actually equal to 11,500. And what more do they want? How should the owners of the team set the ticket price? Well, we've already figured that out. So the ticket price should be 11.50. And that's all.